Welcome back to COSE 1437. This is chapter 8. In this lecture, I'm going to go through and just go over the PowerPoint very quickly. The last one I went through and just showed how to actually create a class and talked about a lot that's here in this PowerPoint, but want to make sure that you hear the terminology again, okay? Because some of this is very new to a lot of students. So this is the example of the string class that we've used many times, starting with our very first program. This is what the skeleton of the string class looks like. It has the keyword final, class, string. We haven't talked about final yet, but here class, this is a reserved word. Final is reserved, and the name of the class is string. Names of the classes, as you've noticed, they start with a capital letter, and the rest of the letters are lowercase. Then in here, we see 1, 2, 3 members of the class string. This string has many other member methods, but these member methods are compared to, concatenate, and to lowercase. So you've used some of these. Notice it has the return type, and they're public because when you define a variable as a string, you need to be able to use these methods. And so that's why they're defined as public. Inside the brackets, we would have the code to compare the two strings, to join the two strings, and to convert all the characters of the string to lowercase. Class is a reserved word. A class is a collection of a fixed member of components. So remember yesterday, or it was for me yesterday because I recorded, but in the last recording, I talked about the different members of a class. So you have a fixed number of members of the class, which includes the data, which are your fields. It includes the constructors, which is like, how do I create this object? Do I get to pass it a value? Do I not pass it anything? Like with string, you can construct a string, an empty string, or you can construct a string and pass it a string. And there's different ways to even do that and how you pass the string. And then the other member of a class are the methods that access the private data. Components are members of a class. Members are accessed by name. We have class categories or modifiers. We can have private, protected, or public classes. A private class, all the members of the class are not accessible outside the class. So if you create a private class, that means that this class is not going to be used by just general users. So you're not going to share it with other people in the company. You're not going to be sharing it with people who may need to use this class. Public means that all the members of class are accessible outside of the class. By the way, with private, what we would make in a class, typically, we would make the data private, and you could have some methods that are also private. They would be methods that are used by other methods in your class. They're not methods that users need to use. Class members can be methods or variables. Variable members are declared just like any other variable is declared, and you saw that in the last video. This is the syntax for defining a class. We have the modifiers, class, class identifier, modifiers, class members. If a member of a class is a named constant, you declare it just like any other named constant. So you would say final, double X equals whatever. And if a member of a class is a variable, you declare it just like any other variable. So like int X or int Y. If a member of a class is a method, you define it just like any other method. So that's why we had a whole chapter about methods, because they're very important in classes. And you need to be able to understand about passing parameters or arguments to your method and then returning a value from the method. If a member of a class is a method, it can directly access any member of the class, data members, and methods. So in the class, in the last video, we had a class that was called Circle, and the class Circle had a method called Area. Well, that method Area can access the perimeter method, and it has access to the data, which was radius. Therefore, when you write the definition of a method of the class, you can directly access any data member of the class without passing it as a parameter. So it's like having this global data that you can use in all your methods, and you don't have to pass that data to the methods. Data members. So this is a class called clock. So they're going to show you, there's an example in your book called the clock class. And in the clock class, there are going to be 3 fields or 3 data members. And these 3 data members are private. They're going to be hour, minutes, and seconds. Hour, minutes, and seconds. So what it means to be private inside the clock class, it means that nobody outside the clock class, when you create an object of type clock, you can't directly change the hours, minutes, or seconds. You have to do it some other way through a method. So here are the methods that this class is going to have. The methods are set the time. So if I create an object like clock C equals new clock, then I can say C dot set time. C is my object of type clock. C dot get hours, C dot get minutes, C dot get seconds. So set time, if I call set time, C dot set time, then I have to pass it 3 integers, hours, minutes, and seconds. If I call get hours, I don't have to pass it anything. It's going to return to me the hour. This one returns to me the minutes, the seconds. This one just prints what time it is. This one, increment seconds. It's going to probably, increment by 1, the minutes, increment by 1, the hours. Equals, this is going to check to see if this clock object is equal to another clock object. So are the times equal? Make a copy of the time, get a copy of the time. Notice when you do get copy, you're returning the clock object, and when you make a copy, you're passing it the clock object. So you're copying the object which has hours, minutes, and seconds. 2 types of constructors, with parameters and without parameters. So we have the constructors. The constructors are going to build the object, and you want to be able to build, like if you're doing clock, you want to be able to build a clock that you don't pass it any parameters, or one where you pass it the minutes and the hours and the seconds. So when you're creating a constructor, which I showed you in the last video, this is a lot of words. So I just want to show you what this last slide is saying. So this previous slide is saying you can have constructors. Constructors are going to have the same name. The name of the constructor is the name of the class, always. Now, the reason that you can do that is because your constructor should have different parameters. If not, it's going to cause an error. So this one has 0 parameters. This one has 1, 2, 3 parameters. And you can have as many clock constructors as you want, but the parameters have to be different. So that you call that the signature. The signature is like this whole thing here. So the signature that talks about here have to be different. Constructors are automatically executed when a class object is instantiated. We instantiate a class object by saying clock C is going to be our object, equals new. New is the one that instantiates new clock. You can say new clock with empty parentheses, or like this, or new clock and pass it 3 values. So here we're showing our 3 integers or data, the data that this clock class is going to contain. And then here we show all the different methods and the 2 constructors. Constructor, constructor, method, 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 all the way down. So this is a unified modeling language class diagram. So this is in UML, this is how we diagram a class. At the top, we have the name of the class, then the data fields, then first the constructors, and then the methods. The general syntax for using the operator new is the following: new class name. And you saw that yesterday when we created the circle class and created a circle object. So we can say, so here we're defining this object, my clock of type clock, your clock of type clock. Here we're instantiating it, so we're making a new clock. This one's going to be empty. This one's going to have 3 integers. So we have my clock and your clock. My clock is a reference variable. Remember that when you do this here, it doesn't create minutes, hour, minutes, and seconds. This is just an object that contains the address of where, I'm sorry, this is a reference variable that contains the address of where the object is. So this is a reference variable, reference meaning it's going to contain an address. That's what reference variable means. Contains the address of where the object is found in memory. So it points to the address. Again, your clock is a reference variable, points to the clock object that contains hours with 9 hours, minutes with 35, and seconds with 15. The syntax to access a data member of a class, object, or method is reference variable name dot member name. So if we create my clock and your clock, there's my clock and your clock. They're of type clock. And here we made a new clock and a new clock. So these are our reference variables. So we use reference variable dot set time. So this is the method. My clock dot print time. This is the method. It goes and it prints the time, sets the time to whatever 3 values I have here. Here I'm calling dot equals to see if your clock is the same as my clock. Are they equal to each other? My clock equals your clock. So here you're assigning your clock the address of your clock is being assigned to my clock. So that means that your clock and my clock are going to point to the same object. So my clock will point here and your clock will also point there. This is a make copy. So if you make a copy of it, then my clock is going to look exactly the same, or your clock is going to look exactly the same as my clock. Objects, my clock and your clock, after the statement, my clock may copy executes. So here's your clock. It has 7:27:36. So that 7:27:36 gets passed to make copy, and it gets copied to my clock. Public void set time. So this is how they've implemented set time. And set time you would pass it hours, minutes, and seconds as integers. And then you would check if hours is greater than or equal to 0, and hours is less than 24, then hour equals hours, else hour equals 0. So it's making sure that you set the hours at a correct number. Minutes can be between 0 and 60. And it has to be less than 60, not less than or equal to 60. Because once you hit 60, it's 1 hour. So you're up here. And then seconds has to be 0 and less than 60. So 0 to 59. So let's say that my clock has 12:36:49, and then I say my clock dot set time 3:48:52. Now my clock now my clock went from this to this because it assigns it to the fields in the clock method. So this would be get hours, would return hour, get minutes, would return minutes, get seconds, would return seconds. Remember that the return type here has to match what's being returned. So HR, hour, better be an integer because that's what you are saying that's being returned. So this is how they would implement print time, increment hours, increment minutes. Make sure you look at increment seconds, all of that. This would be equals. Is it equal to one another? Equals again. How to make a copy. Definitions of the constructor and methods of the class clock continued. So this is the constructor clock. No, so this is a method called get copy. And it returned the clock object. Objects, temp, and your clock. So here's temp, here's your clock. They both have the same data. And then my clock and your clock also have the same data. Okay. Clock get copy. So this gets a copy of, or makes a copy. So clock temp equals new clock, and we pass it hours, minutes, and seconds, and return temp. This is how they define clock, constructor with no parameters, or you could do it this way, what you call set time. Pass it 3 zeros. Here's how clock is implemented, making sure that we enter a valid hour, minute, and second.